Hi! In this video, we continue where we left off in the previous one. So that means we're moving code from the blueprint to C++. In the last video, we set up the basic of the object with all the components, and now we're going to actually use those components to make that platform move. Let's get started. So what we want to do is actually reproduce the functionality we had in the blueprint. So let's take a look first at what we did just to kind of remind ourselves. So there it is. In the blueprint, what we were doing is on the begin play event, we were storing the actor location for the start position. We were storing also the end position, and we were setting the target location to the end position. And we were setting a Boolean is going forward to true. So we're going to go ahead in C++ and reproduce this exact behavior. So back in our code editor, we're going to add a private section here. And we're going to add our variable that we need for that. So they are f vectors, start location. We have another one, vector and location. And we have a third one, f vector, for target location. Here it is. Okay, so with these three variables, we should be able to go in our begin play here and start kind of initializing them. So we're going to go and say start location equals, we are in an actor, so we can do get actor location. There we go. The end location is going to be our target. Sorry, I don't remember. Stop point. It's stop point, which is a scene component. So it's going to be a stop point get actor location. In fact, it's not the actor location. It's no, it's a get world location, I think. Let me check. Get world. Oh yeah, because it's a component. It's get component location. Sorry, I can add a little bit of a and we kind of want it to be in a world coordinate, but I think it is by default. Yeah, in world space. So we're good on that point. So we have that, and we want our target location to be, for now at least, the end location. So with that, it initializes all our variable that we need, like we did in our blueprint. So let's go and see what we did next in blueprint. So the next thing we did here was we were on the event tick, we were moving our platform towards the target location. So we had a custom function called calculate new location. If we go inside, we were using the speed, normalizing our location minus to get the direction, multiply by the speed, and moving with that in the event graph. We were using that to say if the actor is not at this location, he should move, then set the actor location to the calculated location. So we're going to reproduce this exact graph in CPP. All right, so let's go ahead and create that function in C++. It's going to return an f vector, and it's going to be called calculate a new location. Here we go. For that to work, we're going to go and generate the CPP definition here. What we want to do here is we want to get a normalized direction. So we're going to go and say direction equals target location minus get actor location. Since our mesh is kind of the root, then we can treat as they have the same position. He has the same position as the actor. Now we want to normalize it. This is an operation that happens on itself, so it has no really return type or anything. You just call it like that. So it's going to return a normalized vector, and then what we want to do is return the direction time speed that we're going to have to create, time delta time. Oh, yeah, in fact, we forgot we were going to need the delta time. And plus that get actor location, which is a location we already have. So delta time is something that we have in the tick function, so it's going to get passed to us. So let's add it here and in the definition here. So float delta time, and then let's create that speed variable. U property, edit. I'm gonna go with edit default only because I want my platform to have the same speed. You could go with instance only or edit anywhere. It doesn't really matter. It's up to your design for that. We can let's say go read only in Blueprint, and then category equals platform, and then it's a float and it's speed, like this. So now that we have our speed, let's go in our tick function. And now what we want to do is we want to set the actor location to actually that that new method we have. So calculate new location, and we can pass delta time. So whatever this returns us, it's going to be our new actor location. So I'm going to go ahead and go in the engine, and we're going to go and just set up that speed. So we're going to go into our big moving platform. We're going to go and edit the blueprint. So let's go in here, blueprint. We have our BP platform. No, it's a BP moving platform. Sorry, it's not that one. It's the other one, BP moving platform. Now, here we want to set the speed to 75, which was the same one as we had for the normal platform. And now we can play. And there it is. No, it is not working. In fact, I need to compile. I didn't compile the code, so let's go ahead and compile. So there we go. Now it's finished, and then we can play. And then we have our platform moving. There it is. So right now we only did the way forward. We didn't really do the other way around. So we're going to go ahead and make it be aware of the direction that flip that direction once it arrive at destination. So to make the platform go back and switch the direction, the only thing we need to do is we're going to say here if get actor location this distance from the target location is smaller than I think we put 0.1. Distance is expecting, oh, it's expecting 2 vector. Yeah, okay. So we can do it another way. We can just do like f vector as a distance, and then we're gonna pass him first argument there, and then we're gonna put the other one at target location. Here. No, this is this. Here we go. So if this is smaller, our distance is small. Our distance between our location and the target location is smaller than 1. Then we're gonna do. We need the boolean, right? We need the boolean to say if we were going forward. So we're gonna say bool b is going forward equals true. Let's initialize it because by default, otherwise it's gonna be false. And then we're gonna say if b is going forward, then target location equals start location. Else, so let's go else. Oops. Target. Oh, sorry, I forgot here. Here. Target location equals end location. There we go. So with that, we should be able to just move the platform back and forth. Oh, before we test this, we just need to flip the boolean. So whatever here is, we're gonna say b is going forwards equals the contrary. Here we go. Now we can test that. Once you launch back the project, or if your editor was already open, don't forget to compile. We're gonna test this. So now we set the speed already in the blueprint, so we don't have to do it anymore, and then we can play. So here, yeah, if I go on the platform, it should go up, and then after that, it's gonna go down. There it is. So with that, we kind of have the same behavior that we had in our C++, and then we can do platform that move back and forth between 2 points and move that point anywhere, and it's gonna just work. And there it is for the video on the moving platform done in C++. So as you saw, it was pretty quick to prototype the whole thing in Blueprint, but then whenever we were sure of the implementation, moving it to C++ was super quick. And then you get all the good part about C++, which is you get that real Blueprint effect. You can take that class and put it into another project to get a moving platform already set up with already all the functionalities. And then you also get that speed boost from just running in C++. It might not be obvious for a moving platform because it's a small chunk of code, but it gets more clear whenever you get to bigger code. If you like the video, please like, share, and subscribe. Thank you for watching, and I'll see you in the next video.